So, a police siren alternates from a high tone to a low tone. When it's switched on, the siren begins at a frequency of 900 Hz. Then, over 1 second, it gradually lowers down to 600 Hz. Model the frequency of the siren using a sine or cos function. So what we'll do first here is we'll do a table of values. So when it's first switched on, so immediately, so at 0 seconds, where are we? What happens when we switch it on immediately?
0.
But what's our frequency?
Nothing.
When we turn it on? 900. Yep, it's 900 Hertz. After 1 second, what are we at?
600.
Okay, after 1 second, how many hertz what are we at? What's our frequency after 1 second?
600.
600 Hertz, it goes down to 600. Alright, what about 2 seconds, where would we be? It alternates, it goes up, down, up, down. Yep, we'd be back up to 900. 3, 600, 4, 900. So it just goes back and forth. We can graph this. So it starts up here at 900, goes down to 600, 900, 600, 900, etc. Alright. So, what do we got to find? What's our procedure? How would we find the equation that models this siren, the tone, the frequency of this siren? What's our steps?
Find A.
Okay, find A. What's our A value? How do we find A?
Max minus min. So in this case it's 900 minus. Excuse me, are you at them? Yes. Okay. Keep going.
Okay, so
2. 900 minus 600 divided by 2.
so what's our A value? Awful 5, but it'll do. What do we want to find next?
K.
K? Alright. How do we find K?
So we have to find a period.
Okay.
Our period is 4. No.
What's our period? What do you think?
4 seconds.
Why is our period 4 seconds?
Because that's where it ends.
It ends. This graph ends at 4, but our period doesn't necessarily end at 4. 3 seconds. Why is it 3? Explain your reasoning. Yeah.
Because it ends.
Alright, so decide where you want to start.
It ends at 2, man.
Alright, let's decide first.
Smart guy.
So first thing we have to decide is we have to decide, are we using a cos or a sine?
Sine.
Why would you think that?
Because the peak. You start with the peak.
Okay.
Sine or cos? I think it's cos, man.
Alright. So you were actually on the right track there. We should use a cos because we're starting on the y-axis with our peak. A cos function starts with the y-axis at its peak, 0, 1. In this case, it's 0, 900.
Yeah.
But it's the same idea. So cos function would be the easiest. So if our function starts here at 900, where does it at 0 and 900? Where does it end in terms of seconds? 2, right. So if our function starts at 0 and ends at 2, what's our period? What's our period here?
180.
Nope.
It's 360 by 2.
No, what's our period, not our k value?
Oh, it's 2.
Okay, so our period is equal to 2. And our k value is equal to 360 divided by our period, which is 2. So our k is 180. You are correct.
Yes, sir.
What do we want to find next?
So K.
We found our k value. We found our a value. What's left?
K is 1.
C and D. Alright, let's pick one. C or D. Which one do we want to find?
C.
Alright, let's find C. What do we have to find first if we're finding our C value? The what? Probably didn't hear that.
The axis of symmetry.
The max minus A. What does that get us?
No.
Now, what is it called?
This
When it
axis
goes right through the middle. Yep, it's the axis of symmetry. So, our axis of symmetry is equal to our maximum minus our A value. So what's our maximum? 900. What's our A value? 150. So what's our axis of symmetry?
750.
Okay. Alright, so if our axis of symmetry is 750, what is the axis of symmetry for a normal cosine function?
0.
0, exactly. So, what happened to this one if our axis of symmetry is at 750?
Shift it up.
It shifted up by 750.
Wow, 700.
It's a long way to shift up. What does that make our C value? 750. Last but not least, we have our D value. Okay, so where, in terms of the x-axis, where does a cosine function normally start?
0.
It's 0. In this case, where does our function start?
Oh, it starts at 900.
No? Well, 900 on the y-axis. Yeah, you're right. It starts at 0. So if it normally starts at 0, and this time it starts at 0, what does that make our D value? How much have we? 0. We've shifted by nothing. So our D value is 0. Our A value was 150. What did we get for our K value?
2.
That was our period. Our period was 2. What was our K value? 180.
Okay.
What did we do next? We got our A, we got our K. What did we get next? C. What was our C value? Plus 750. What about our D value? 0. Alright, so can somebody walk me through this equation? What did we do? How do we write this?
We use cos
Yeah, y equals
150 cos
150 cos bracket.
180.
Okay,
John, put it away.
Bracket x
okay.
close bracket plus 750.
Plus 750.
It's not good.
Yeah. Yeah, hang on. Alright, so our final equation here would be y is equal to 150 cosine 180 x plus 750. A group of environmentalists were studying a local rabbit population. They found that the population of the rabbits peaked at 7,500, 3 weeks after their study began. Then they saw the rabbit population drop to 3,500 before beginning to climb again. They observed this at 7 weeks after their study began. Model the rabbit population with a trig function. Okay, so alright, let's find A. Look at the square that says find A at the top. Alright, so how do we find A? What's our usual? Okay. Alright, so our usual is A is equal to max minus min
Yes.
divided by 2. So what's our maximum?
2K.
750. I'm 7,500.
Yeah, 7,500. What's our minimum?
500.
3,500, right. So what does that make our A value? If it's 7,500 minus 3,500 over 2, what's our A value? 2,000. It's 7,000 minus 3,000 divided by 2.
So it's 2K.
You gotta put the divide by 2. Yeah. A is 2,000. That is the value of A.
Yes.
And we got that using our maximum of 7,500, our minimum of 3,500, and our formula, A is equal to max minus min over 2. Let's find C now. Okay, so what's the first step when we're trying to find C?
You gotta find the axis of symmetry.
Yep, you gotta find the axis of symmetry. How do you find the axis of symmetry? Just using the words. Alright, so the axis of symmetry
Is 5,000.
is equal to A minus max. So what was our...
1,500.
So wait, it's not A minus max, it's max minus A. Sorry about that.
Yeah?
500.
5,500? Okay. So our maximum is 7,500 minus our A value of 2,000. So our axis of symmetry is 5,500. So now we have to decide. Do we want to use a sine function or a cos function?
Let's use the cos function.
Okay.
Side.
You want to use a sine? In this case, I don't think it really matters.
Yeah.
Okay.
Use side.
We want to use a sine? Alright, we've been using cos a lot. Let's give sine a try. Either way, sine or cos, what's the axis of symmetry of a sine or cos function? 0. What's our axis of symmetry here?
3. No.
5.5K.
Yeah, 5,500 is our axis of symmetry here. So what happened to the axis of symmetry?
It shifted 500.
Yep.
500.
It shifted up by a value of 5,500.
The K?
The axis of symmetry.
Oh, okay.
We're still on C. So if our axis of symmetry shifted up by 5,500, what's our C value?
5,500.
Yep. K was the tricky one. Does anyone remember how we figured out K yesterday? How do we figure out K?
You do 360.
You do what?
You gotta find
Alright, you gotta find the period first. Right, so how do we find the period in this word problem? How do we find the period? That is tricky.
It's kind of hard when you don't have a graph to see.
Yeah, you don't have a graph to see, but we don't need a graph.
Yes, we do.
No, you don't.
We don't need a graph.
Alright.
You do, smart guy.
Alright, so the way you find the period without using a graph, if we looked at, remember yesterday when we looked at a regular cos function?
Yeah.
The distance between the maximum and the minimum was what?
The half.
Half of what?
Half of
Half
the
of
period.
the
Alright, so when does our maximum occur?
Half.
In this
So 500.
question?
500K. 5,500K.
no, that's not.
No, when did our maximum occur?
7,500.
Yeah, when did that happen?
At
Few weeks after.
3 weeks after.
Mm-hmm. Alright, so when did our minimum occur?
7 weeks after.
Okay, so what's the time between that?
5.
5 weeks. Alright, so what is 5 weeks then?
5?
Oh, 7. Oh yeah, you're right, it's 4. Sorry. 4 weeks.
4.
4 weeks. So what is 4 weeks then? 7, 6, 5, 4. Yeah, it's 4.
4.
7 minus 3.
7 minus 3.
Yeah. Our maximum occurred at 3 weeks. Our minimum occurred at 7 weeks. The time between those two is 4 weeks. So, what is 4 weeks? What does that mean? Is it the period?
It's half the period.
It's half the period. So the time between our maximum and our minimum is half of the period. So, if half the period is 4 weeks, what's our period?
8.
8 weeks. So our period is equal to 8. If our period is 8 weeks, how do we find the k value?
360 divided by 8.
Yeah. So our k value is equal to 360 divided by k, or period.
45.
It's okay. Equals 45.
So our k value, you're right, it's 45. Last but not least, let's try to find d. What did we decide we were going to use?
Sine.
We're going to use sine this time? Alright.
We chose sine though, right?
Yeah, we chose sine this time. Sine is a little bit more difficult to use in these problems, but we can use them if you want to. Do you want to go the easier way?
I told you guys cos was easier.
So what do we want to do?
Let's do sine.
Let's do sine. Alright, so,
I chose it.
okay. So, if our maximum occurred at 3 weeks, how long will it be till it hits the axis of symmetry? How much of the graph is that, like between the maximum and the axis of symmetry? No, that's when 3 weeks is when our maximum occurred.
Okay. And we got to go down.
So we're at 7,000.
1,500, right? From the top to the axis.
2,000. 2,000 is our A value, so we got to go down by 2,000. What happens when? Yeah. 5,500. What happens when? How long till it hits our axis of symmetry?
How long?
Yeah. If our maximum occurred,
4 weeks if it's half.
but it's not half. Between the maximum and the axis of symmetry is,
2,000.
yeah, in the y values, but what about the x values?
Okay, so 3 weeks.
Nope. Half of the period is what?
4.
So 1/4 of the period would be
2.
2.
Bang it.
So it's 2 weeks.
Ah.
So if we want to start,
This is too difficult to.
yeah, I just realized this isn't going to work either because then we'd have to make the a value negative as well. So let's just use a cos function because it's just way easier this way.
Boys, Adam and John.
Okay.
And John.
So, all right, guys. So, when does cos function start? What's the start of our cos function? At the 0 along the x-axis. But what about the y-axis? Which is the max? All right. Where the max occurs is our d value. Exactly. So where does the max occur this time? How much time goes by?
3 weeks.
Yes. So normally, a cos function starts at 0. But this one doesn't start at 0. This one started at 3 weeks. Okay? You understand how we got the d value?
Kind of.
Okay. Alright. Alright. So we've shifted to the right by a value of 3, making our d value plus 3. So now we can recap. We've gotten everything. What's our a value? What was our a value? What did we determine the a value was?
2,000.
Pardon?
2,000.
2,000. What was the next one? What did we do next? We got the c value. What was the c value?
5,500.
5,500. What was next?
Okay.
K value. Alright. What did we get for a k?
45.
45. And last but not least, our d value. What did we get for our d value? 3. Alright. So someone walk me through this equation. What is this equation? We decided to use cos. So what is this equation? I know I took them off the board. Alright.
2,000
Y is equal to 2,000
cos
cos
bracket 8.
bracket what?
K is 45.
Okay, yep. Okay,
Bracket
yep.
x minus 3.
Mm-hmm.
Cos bracket
Hang on a second.
plus 50.
X minus 3 bracket and C is plus 5,500. Alright, so our final answer for this question is y is equal to 2,000 cos bracket 45, bracket x minus 3, close bracket, plus 5,500. Alright.